Hello everybody. Thank you for watching my YouTube video. I'm glad that you are doing well. In this demo, I'm going to talk about Kubernetes architecture. The first thing I'm going to talk about is a master node. Master node is usually set up on IN for HA to achieve high performance and failover purpose to reduce downtime. kubectl is used to interact with cluster apart from using the cluster through Kubernetes dashboard or through API. You can mainly call the kubectl from the dashboard and the API. kubectl is mainly is main utility to interacting with Kubernetes from the command line. API server. API server provides RESTful Kubernetes API to manage cluster configuration backend by the etcd data store. etcd is a key value store designed for strong consistency and high availability. Kubernetes uses etcd to reliably store master state and configuration. The various master components watch this data and act accordingly. For example, starting a new container to maintain a desired number of replicas. Kubernetes uses the etcd to store configuration data that can be accessed by each of the nodes in the cluster. This can be used for service discovery and help the components configure or reconfigure themselves according to up-to-date information. It helps maintain cluster state with features like leader election and distributor locking. By providing simple HTTP JSON API, the interface for setting and retrieving value is very straightforward. Scheduler. Scheduler places an unscheduled pods on nodes according to rules. At this stage, scheduler is simple, but it's like a most components in Kubernetes plug and playable. Control manager. Control manager is a manages all the cluster level function, including and creating and update endpoints, node discovery, management, and monitoring of pods. Replication controller. Replication controllers which normally used to for the control and coordinate and all the pods and maintain the server as a configure on a cluster system. Secret. Secret is where is used to encrypt and keep the confidential data. HPA is an horizontal pod autoscaling, scales with CPU criteria or memory limits. Event is used to keep the log of the clusters and the nodes, and the namespace is normally the limit for you can set a limit for the resource quota by define or you can define on the namespace with the CPU, memory, pods, and how many users, those kind of functions you can provide. Here is the flow of the architecture diagram. Normally kubectl will talk then authorization, then you can use the API and you can schedule the number of pods and how the flow talks to the etcd store, etc. Coming to nodes. The worker nodes, the number of worker nodes depend upon the size of the cluster. It can be but one of it's uncommon to have Kubernetes cluster with over 2000 nodes. The size depends on your budget and the use cases. Each worker node runs the following services. Kubelet. Kubelet is a service that receives the order from the master container and runtime, which with which it interacts to the manage and container instance. Kube proxy. Kube proxy provides simple network proxy and load balancing capabilities. Kubeproxy enables the service to be exposed with the network address and the name. Docker. Docker is a container engine responsible for creating the pods on each slave node. To run the container, it has to download the image from the Docker registry. So the architecture diagram shows you on the node level how the connection and how the user normally get interact and the flow comes when the user access the pod, it goes to the service, and then using the IP tables it is getting forwarded to the pods. And thank you all. In this video I've covered the architecture diagram, and at the same time I also talked about the key components of the Kubernetes architecture. So In the next video, we will discuss about the Kubernetes installation using a master and 3-node cluster and at the same time using Minikube. Thank you all.